Hello and welcome to Master CFD. In this video I'm going to show you how to generate the geometry and the mesh of this product Airflow around a NACA 0008. To get the points of NACA 0008 you can search it, and then if you click on this side, yes, you can see that in Airfoil tools side the points of this curve is presented. First of all, you should click on this one, send to Airfoil plotter. Yes, here is the curve, and now you can click on CSV file of coordinates. Yeah, this way you can have the information of the points in an Excel file. If you open it, yes, so these are X and Y information about airfoil surface. But now I want to show you how to actually transfer this information to Design Modeler. First of all, create a column like this, and then continue until the last row of this column. Then create a column in which the numbers are in order like this, and then choose both columns of X and Y, copy, and then paste it here. And now create a column in which all the sections include 0, and then write X, Y, and Z here. Now choose all these 5 columns and right click on it, copy, then paste it in a notepad file, and now save it as a text file. Let me name it as NACA 8. Okay, and now save it. So later I will explain for you how to read this text file in Design Modeler. To start generating the geometry, first you should open your workbench window, and here you can select Fluid Flow Fluent and drag it to the blank window, and here the geometry is the first section. If you right click on it, you can select this one, New Design Modeler Geometry. Design Modeler window is opened like this, and first I should read the points from the NACA 0008. To do that, go to Create, select Point, and here definition should be from coordinate file, and here I should choose my file. Then click on generate. As you see, the points are shown in the window. And now it's time to create a line from these points. To do that, go to concept and choose a line from points, and then you should choose the points one by one and try to connect them. Do not forget to get Ctrl key on your keyboard so that all the points are selected and you can create the line before them. So I kept on selecting all the points, and now all of them are selected. And now I want to close the end of this curve. Then I will correct the shape in Spaceclaim, because Spaceclaim is more user friendly. So one more time, I want to connect these 2 points, and here click on apply. As you see, 35 points are selected, and here you click on generate. So yeah, the line is created between the points. Now I want to close Design Modeler, and now right click on Geometry, then open it in a Spaceclaim. So by right click on the geometry in the filament box in Workbench window and choosing edit geometry in a Spaceclaim, the Spaceclaim is opened like this, and we have the airfoil here. But now I want to change the end of the airfoil so that it would be in the right shape. To do that, go to sketch part, and now by choosing line command, I can click on the end of the airfoil and try to draw a line in which it would be closed and in correct shape. So if I double click and then do the same with the other end, again double click. So yeah, now I can remove this edge by this one, trim command, and now I have it correctly. Now I continue drawing the other parts of the geometry. First I choose rectangle command, and from this point I draw a rectangle in which the length is 1500 meters. Yes, like this, and by choosing dimension I can change this dimension in which it is 1000. Yes, and now I can repeat this rectangle by choosing mirror command and choose this this line as the mirror plane, and ask the software to repeat these sides for me. Now it's time to go to this point, and by choosing line command, draw a line by 1000 meters. And now by choosing this argument from this point to this point, draw an arc, and now do the same with these 2 points like this. Okay, now it's time to scale the geometry because I want it to be smaller and scale it 1/100. To do that, go to Pool Tool, and now scale body. Now it asks me to choose an anchor point. Then select all the surfaces and ask the software to scale it 1/100. Yes, now the geometry is scaled and now is smaller in which we wanted it for the product. But the next step is removing inside the airfoil because it is surface, and so by clicking on it and right click and cut, yes, now inside the airfoil is empty and now we have the domain around it, and actually this is the surface. Now everything is ready. Now we can transfer it to Ansys Machining to be meshed. After closing the Spaceclaim window, you can see green check mark is like this, and now we can double click on mesh so that meshing window, Ansys Machining window will be opened. So yeah, now the geometry is exported to Ansys Machining successfully, and if you zoom in you can see the geometry in details. Now I want to give size to different edges. To do that, I choose these 3 edges and insert. I can do it from here. Right click, insert sizing, then choose my edges 1, 2 and 3, and here click on apply. Yes, 3 edges are selected, and now change the type of meshing to number of division. I try to put number of division to 200, and then I want to give bias in this way, and bias factor would be 10, meaning that the biggest element is 10 times bigger than the smallest one. And now I should check if the bias is reversed or not. So yeah, 2 edges are reversed, so click on them, 1, 2, apply, and now all of them are in right bias. Next, I want to give size to other edges. Again, right click on mesh, insert sizing, and choose these 5 edges, apply, element size should be changed to number of division, and I want to give 150 number of division, and of course they should have bias this way, and give 20 as bias factor to them. And next step is giving size to these edges around the airfoil, because there are some edges that are separated from each other. I prefer to give element size to these edges, not number of division. To do that, again, mesh, insert sizing, and choose all of them. So yeah, keep on selecting all of them. And the last one, and apply. Yes, 36 edges are selected, and here type is element size, and I want to give 30 millimeters as the element size. That's it. Next step, I have to insert method for the whole meshing. I choose my geometry here and click on apply. Then I change the method to multi-zone, and here free face meshing type should be in all quad. That's it, nothing else. And now if I click on mesh and generate mesh, meshing will be done for me. So the meshing is done. Just I forgot to say that this geometry needs to be actually done with face meshing. To do that, you can right click on mesh, insert face meshing, then like this, select your geometry, then apply, and method should be in quadratical, and after that click on generate mesh, then the mesh is done. So yeah, this is how the geometry is meshed. I hope this video is helpful for you. To benefit from Mr. CFD services including simulation, consultation, and training, visit our website www.mr-cfd.com or contact us via info@mr-cfd.com.